Hello, this is Allie Hall and Kate Noble for our presentation of data sets for our final project. We chose
We'll send you this PowerPoint.
We chose the 1D life expectancy, and we have variables that are female life expectancy, male life expectancy, country, people versus the number of TVs in the country, and people versus the number of doctors in the country. We did observations, and we found the best stat test to do would be a paired t-hypothesis test. And our research question is, do life expectancies differ by sexes, female and male? And if so, if they do, then how so? Our exploratory data we found from using StatCrunch. We found that our female life expectancy mean, average mean is 69.075, and the male life expectancy mean is 64.5. So using our t-hypothesis test, we are calculating the mean of the difference between male life expectancy and female life expectancy. So here is our hypothesis. It'd be female life expectancy minus male life expectancy. Our null hypothesis is equal to 0, and our alternative is not equal to 0. So we found, when we did the test, we found that the mean of difference is 5.075. Our standard deviation is 0.382. Our test statistic is 13.252. Our degrees of freedom is 39. And the p-value is 0.0001. Less than. So we reject the hypothesis, and that gives us sufficient evidence to support that there is a difference between female and male life expectancies, a significant difference. We also used the goodness of fit test, and this test is a test of normality, and we found that since we have samples that are greater than 30, that tells us that we know we should use the paired t-test. So in conclusion, the answer to the question, our research question, is yes, there is significant difference in life expectancies between female and male genders, and we know this because our p-value is less than 0.0001. Our female mean is 69.075, and the male mean is 64.5.
Okay, the second data that we used was the 2E cigarette. Our independent variable would be the 43 states and the kidney, bladder, and lungs, and then the dependent variable would be the cigarettes. So our observation, the test that we chose to use was the multiple linear regression test. Our research question was taking note that cigarette sales can be swelled by tourism, find a best linear model to predict the number of cigarettes smoked/sold using any or all of the other variables. So this is our data that we got after the multiple linear regression test, and our alternative hypothesis is set to not equal 0, and then our null hypothesis is set to equal 0. Our t-stat for intercept was negative 0.35. Our t-stat for kidney, which is one of our independent variables, is 2.46. Our t-stat for bladder is 2.76, and our t-stat for lung was 3.13. Our p-values were 0.725 for intercept, 0.018 for kidney, 0.009 for bladder, and 0.003 for lung. So we chose the multiple linear regression graph, which you can see right here, because there were multiple variables and there were few outliers. The margin of error you can see is very small, and there are no visible trends on the graph. The end.